theorem. Okay, so first of all, before I start, I want you to understand these things. Okay, before I start with what I'm about to teach, I want you to understand this. In algebra, okay, the addition and the subtraction sign, they separate terms or they define terms. Okay, so when you have an expression like ax squared plus bx plus c, okay, this is a quadratic trinomial because it has been demarcated into three terms. It is a trinomial because it has three terms, and it is quadratic because of the exponent 2. So this is the first term, the second term, and the third term, and they are separated by the addition sign. Do you get it? That's the role of the addition and subtraction. They define terms, but the multiplication and division will combine the term. Okay, so what we are doing is we are focusing on binomial theorem. Bi means two, right? So binomials, and this binomial theorem is expansions. So what I'm expecting of you is that at the end of this course, you should be able to do these expansions. No, not even at the end. Like in 5 minutes from now, like you should be able to do this. Like to the power 2, 3, 4, 5, 6. Okay, so this one becomes a squared plus ab plus b squared, right? Here will be 2. A squared plus 2ab plus b squared. Okay, so this one becomes a cubed plus 3a squared plus 3ab squared plus b cubed. Okay, good. And this one becomes a to the power 4 plus 4a squared cube. A cubed b plus what? 6, no, a squared b squared plus 4a b cubed plus
6
b to the power 4. Don't worry, you understand. Okay, I just want you to know that you can do it offhand. Okay, like how I'm doing it. A to the power 5 plus 5a b to the power 4 plus 10a cubed b squared plus 10a squared b cubed plus 5ab 4 plus b to the power 5. Okay, so you understand. This is just the sixth one. I can do it, but for the sake of time, I want us to do something. Okay, I'm coming to teach you. Okay, I'm coming to teach you how to do this. So there was a man called Pascal. He sat down and he came up with something we call Pascal's triangle. It is a standard that we use in identifying the coefficients of the terms. Okay, so first of all, before I start, I have to explain what a variable is, a coefficient is, and a constant number is. So when you have an expression like y is equal to maybe 2x plus 4, y here is a variable, x here is a variable. They are variables because they are attributes. They accept an input and they can change the nature of the expression. So if y is defined as 5, then the expression's nature will change. So therefore, x will change, will become what? Half. Because when y is 5, x becomes 2x plus 4. So this 4 comes to the other side of the equation sign. So it becomes 5 minus 4, isn't it? Being 2x. So 5 minus 4 is 1. So divided by 2x, you get what? Half. Okay, so therefore x becomes 1 over 2. So that's a variable. So when it receives its input, or That's why I said it's an attribute. Okay, so when it receives the input, it can change the nature of an expression. So x and y are variables. Okay, x and y are variables. Okay, and so I explained it. So if x and y are variables, any number in front of the variable is called the coefficient of the variable. So y here has 1 in front of it, but we don't write it in mathematics. So the 1 here is the coefficient of the y. Coefficient. And the x is a variable. So the odd number, the number that has no variable attached to it, actually has a variable attached to it, but the variable is to the power 0. Okay, so that number is called a constant number. Okay, so this is what we are coming to do. So now you know what a variable is, what a coefficient is, and what a constant number is. Good. So now let's go back to Pascal's triangle. So Pascal sets down. He says that, okay, if I have, there is a general standard in mathematics that any number to the power 0 is what? 1. Okay, so if 5 is to the power 0, it's 1, right? And if 100 is to the power 0, it's still 1. So if a binomial is to the power 0, it is still what? 1. Do you get it? Then he sat down again. And he said, what if the binomial is to the power 1? It becomes what? The same number. Because it says any number to the power 1 is what? That same number. So it becomes what? A plus B. Do you get it? Okay. So, and you know A is a variable, B is a variable. So what are their coefficients? 1, 1. So you realize that there was 1 here, there was 1 here. Okay. Then he took this expansion to the power 2. When he expanded it using the traditional expansion method, you know that one? You multiply this, you get what? A squared, this times this, A plus B, right? A plus AB. So A will multiply this, you get A squared. A will multiply B, you get AB. B will multiply A, you get AB. Then B will multiply B, you get B squared. So when you did that, you realize there became 2. So you got what? A squared plus 2AB plus B squared. But still you realize that the coefficient of the first term was 1. And that of the last term was 1. And you realize that there was an you realize that a middle term was introduced. Do you get it? I don't know. A middle term was introduced. So that middle term, its coefficient was the summation of the two terms in the previous expansion. So you realize that here was 1, here was 1. When you add, then you get the 2. So then he sat down. He tried an expansion 3. That one, when you multiply this to what you get here, you get that one. So when he did that, he got a cubed plus 3ab squared plus another 3ab squared plus b cubed. So you realize that still the coefficients were 1, 1 at the edges. But as time goes on, you see this one was 1, then it became 1, 1. Then the third one here became 1. Then the middle term was the addition of the 1 and the 1 here, and you get 2. Then the last term came here. So that was a streak. That was how he deduced that triangle. So he came here, he started with 1, he added 1 and 2 to get 3. Then he went here, he added 2 and 1 to get another 3. Then he remained the 2. Then he realized that, okay, then the next one will be 1. 1 plus 3 is what? 4. 3 plus 3 is what? 6. 3 plus 1, 4, right? Then he maintained the 1. That's it. 1, 4, 6, 4, 1. Then he went to the fifth one. He knows that it starts with 1 and ends with 1. So when you add this and this, you get 5. When you add this and this, you get what? 10. That's 4 plus 6 is 10. And 6 plus 4, 10. 4 plus 5, 5. Then 1. So that's how you deduce the coefficient. You understand? So that's Pascal's triangle. So Pascal's triangle